Hi everyone, this week's tutorial is based on polar plots, right? So you'll be needing the knowledge of complex numbers. Just in case if you have forgotten about complex numbers and its properties, please do go back and recap on it, right? So let's start off with this week's tutorial. So question number 1 is to sketch the polar plots of 1 by s, 1 by, and 1 by s squared, right? So currently the transfer functions are given in S domain. What we'll need to do is to convert that into j omega form or into complex form, right? So to do that, what we'll need to do is to directly substitute j omega in place of s, right? So let's look at 1 by s. If we do direct substitution of j omega in place of s, we'll be getting 1 upon j omega, right? And the magnitude of this is equal to absolute value of 1 upon omega, and the phase of this is equal to negative 90 degrees. This is because there's only imaginary part of it, right? There is no real part present. So since the phase remains constant, we'll need to see how the magnitude changes with frequency. So when we do that, we get that when omega is equal to 0, the magnitude is equal to infinity, and when omega is equal to infinity, the magnitude is equal to 0. So both of these is at an angle of negative 90 degrees. So when we plot this on the negative side of the imaginary plane, at omega is equal to 0, right, at an angle of negative 90 degrees, the magnitude is infinity, right? So there will be an open circle at infinity, and at omega is equal to infinity, the magnitude is 0, so there will be an open circle at this center of origin, right? So you'll be going from frequency is equal to 0 to frequency is equal to infinity, so the direction of the arrowhead will be pointing towards the center of origin, right? So you'll be getting a polar plot of something like this. Moving on to the second part of this question, that is to sketch the polar plot of 1 by s squared. Again, the procedure remains same, to directly substitute j omega in place of s. When we do that, we'll be getting 1 upon j squared omega squared, right? So we can further simplify this and rewrite it using the complex number properties. That is, j squared is equal to negative 1. So if we do the substitution and simplify it, we can rewrite this as 1 upon negative omega squared, right? The magnitude of this is equal to absolute value of 1 upon omega squared, and the phase of this is equal to negative 180 degrees, right? So since there is no imaginary part, so the phase remains constant and is not affected by the changes in frequency. The only thing that is affected again over here is just the modulus. So we have to see how the modulus changes with change in frequency. So when you do that, we see that at omega is equal to 0, the magnitude is equal to infinity, and when omega is equal to infinity, the magnitude is equal to 0, right? So both of these is at an angle of negative 180 degrees. So when we plot this, right, when omega is equal to 0, the magnitude is equal to infinity at an angle of 180 degrees, right? And when omega is equal to infinity, the magnitude is 0, so there will be an open circle at the center of origin, right? And you will be going from omega is equal to 0 to omega is equal to infinity, so the direction of the arrowhead will be pointing towards the center of origin. So the polar plot of this particular transfer function of 1 upon s squared is equal to, is something like this, right? So let's move on to the question number 2, right? So question number 2 has 2 parts, right? The first part is to sketch the polar plot of k upon 1 plus st, right? Again, the procedure remains same. The first step is to directly substitute s with j omega. So when we do that, we get k is equal to 1 plus j omega t. We can further manipulate this, right? So that we can take j into the numerator, right? When we do that, to do that, what we need to do is to multiply the numerator and denominator with the conjugate of 1 plus j omega t. That is multiplying numerator and denominator by 1 minus j omega t, right? So when we do that, we get 1 upon 1 plus omega squared t squared minus j omega t whole thing upon 1 plus omega squared t squared, right? Whole thing multiplied by k. This k is a constant, so that means the magnitude of these is affected by the constant outside, right? This constant, and the phase over here is not affected by this constant, right? So what we can do is find the magnitude of this and multiply by this k. So right, so the constant only affects the magnitude, right? So if we find the magnitude of this, we'll get 1 upon root of 1 plus omega squared t squared, right? And since the magnitude of this, so when we multiply by k, the k affects the magnitude of this, so the total magnitude of this transfer function is equal to k whole thing upon root of 1 plus omega squared t squared, right? And for the phase, the constant does not affect the phase, right? Remember that the constant does not affect the phase. So we can directly take the phase of this, that will be the phase of the total transfer function, right? So the phase of this is equal to tangent inverse of imaginary whole thing upon real value, right? So when you do that, you will get tangent inverse of omega of, now you'll be getting tangent inverse of negative omega t, right? That can also be written as negative of tangent inverse of omega t, right? So these two are the functions for magnitude and phase, right? For the transfer function k upon 1 plus j omega t, right? So we need to plot this. So the first thing is to check the behavior at omega is equal to 0 and omega is equal to infinity. So when we do that, we get that when omega is equal to 0, the magnitude is equal to k and the phase is equal to 0, and when omega approaches infinity, we get magnitude as 0 and phase is equal to negative 90 degrees. So when we plot this, right, so when we plot this at omega is equal to 0, the magnitude is k, right? So omega is equal to 0, the magnitude is k, so this will be the magnitude k, right? And the phase is 0, right? So there will be a point on this axis, right here. So when omega approaches infinity, right, the magnitude is 0, right, and an angle of negative 90 degrees. So there will be a point at the center of origin, right? So you can do a point by point plotting, right? You can just take some random points and plot this. You'll be getting something like this, and the magnitude of each and every point is given by k whole thing upon root of 1 plus omega squared t squared, and the angle of that particular point is given by negative tangent inverse of omega t, right? So you'll be getting a polar plot of something like this for the first part of question number 2, right? Moving on to question number 2, moving on to the second part of question number 2, right? That is to sketch the polar plot of st upon 1 plus st, right? Again, what we can do is, what we have to do is actually to directly substitute s with j omega. When we do that, we get j omega t whole thing upon 1 plus j omega t, right? So now what we need to do is to identify the magnitude and phase. So to identify the magnitude, so what we can do is magnitude of the numerator divided by magnitude of the denominator will be the magnitude of the whole function. So that will be omega t whole thing upon root of 1 plus omega squared t squared, right? And the phase is given by the phase of the numerator minus the phase of the denominator. So that would be the phase of the numerator is 90 degrees, right? So 90 degrees minus the phase of this denominator, which is equal to tangent inverse of omega t, right? So once we have the functions for the magnitude and the phase, right, we need to check the behavior at frequency is equal to 0 and frequency is equal to infinity. So at frequency is equal to 0, the magnitude is equal to 0, and the phase is equal to 90 degrees, right? So when frequency is equal to infinity, the magnitude is 1 and the phase is equal to 0 as well, right? So when so the polar plot of this is equivalent to something like this, right? You'll be getting a polar plot of this. This is identical to polar plot of part 1, right? But it is inverse of it. So similarly, you have the points for frequency is equal to 0 and points for frequency is equal to infinity, right? You can plot that and take some random points, right? let's say frequency is equal to 10, 20, 50, 100 and so forth, and you'll be getting a shape something like this, right? Each and every point on that is given by omega t holding upon root of 1 plus omega squared t squared at an angle of 90 degrees minus tangent inverse of omega t, right? So when you plot that, you'll be getting something like this, right? So let's move on to the third question. So question number 3 has two parts again. So the first part is to sketch the polar plot of 10 into s plus 2 into s plus 10, right? You can rewrite this as 0.5 holding upon s into 1 plus 0.5 s into 1 plus 0.1 s, right? So as usual, the first step is to replace s with j omega. If you do that, you'll be getting 0.5 holding upon j omega into 1 plus 0.5 j omega into 1 plus 0.1 j omega, right? To find the magnitude of this, right? The magnitude of this is equal to the magnitude of the numerator, that is magnitude of 0.5, right? Magnitude of 0.5, that is 0.5 upon magnitude of j omega, right? That is omega, then multiplied by magnitude of this, that is root of 1 plus 0.5 omega squared, right? Then multiplied by the magnitude of this, that is root of 1 plus 0.1 omega squared, right? Which is equal to 0.5 holding upon omega root of 1 plus 0.25 omega squared times root of 1 plus 0.1 omega squared, right? To find the magnitude function for this, it is equal to the phase of the numerator, that is phase of this, that is 0 degrees, right? Since it's a positive real number, so the phase of this is 0. So 0 degrees minus phase of this j omega, that is minus 90 degrees. Then the phase of this, that is minus tangent inverse of 0.25 omega. Then the phase of this, that is minus tangent inverse of 0.01 omega, right? Then using the functions for the magnitude and the phase, you can tabulate, right? Tabulate the result for a range of frequencies. So for this particular case, we have tabulated for 0, 1, 3, 10, 100 and infinity, right? So you can tabulate the result. So once you have tabulated the result, you can go on and plot these results, right? If you plot the results, you'll be getting something like this, right? The graph will be going from this point to this, right? So you'll be getting a polar plot of something like this. Moving on to the last question, that is part 2 of question number 3. We have to sketch the polar plot of 100 upon s squared plus 10s plus 100. So as usual, we have to replace s with j omega. So when we do that, we get 100 upon j omega squared plus 10 j omega plus 100 using the complex number properties. J squared is equal to -1. We can rewrite this as 100 upon minus omega squared plus 10 j omega plus 100, right? So we can rewrite this, right? We can rewrite this as 100 plus 0j holding upon 100 minus omega squared, right? Plus 10 j omega, right? So we need to find the magnitude and the phase. So to find the magnitude, we have to find the magnitude of the numerator and the magnitude of the denominator. So the magnitude of the numerator is 100 upon magnitude of the denominator, which is root of 100 minus omega squared whole thing squared plus 10 j omega squared, right? The root will be all of this, right? You have to take the root of all of this. So that is your function for your magnitude. To find the function for the phase, we have to find the angle of the numerator minus the angle of the denominator, right? So the angle of the numerator is tangent inverse of 0 upon 100 minus tangent inverse of tan omega whole thing upon 100 minus omega squared, right? So that would be that, right? So this will be tangent inverse of 0, which is equal to 0 minus tangent inverse of tan omega upon 100 minus omega squared. So basically it is minus tangent inverse. So you can just take this as 0. So your phase will be just given by minus tangent inverse of tan omega whole thing upon 100 minus omega squared, right? So you can again tabulate the results, right, using the function of magnitude, right, here, using this function, right, and using the function of phase as well, right, to determine the phase as well. So you can just use this function, right? Again, tangent inverse of 0 is 0, so you can just use minus tangent inverse of tan omega whole thing upon 100 minus omega squared, right? So you can tabulate the results, right, for a random frequencies starting from 0 till infinity. Take random intervals, right, and tabulate the results for omega and tabulate the results for the magnitude and the phase of it, right? So once you determine the angle and the magnitude, you can plot your polar diagram, right? So you'll be getting a polar plot of something like this, right? So that's it for this week's tutorial. If you have any other question, you can post it on Moodle, or you can directly drop me an email. I'll be happy to answer them. And the solutions for this week's tutorial will be also posted on Moodle. So just in case if you are not able to get the solutions, it will be posted on Moodle, right? So yeah, so that's it for this week's tutorial. Thank you.